Live. For those of you listening at home, hi Julia, hi Jonna. We just started, thank God I discovered this early. We're going through trigonometry, which is SOHCAHTOA, sine, cosine, and tangent of theta. Sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. There are three other functions. Can somebody name them? Go. Cosecant. What was the next one? Secant of theta, and then what? Cotangent of theta. Does that mean those spelled out? It's been a while since I've had that. Cosecant, I might as well just write it once. Cosecant, then secant, then cotangent. Jack Lau, what are the definitions of those three? How do you find them?
They're opposites of the reciprocals of the other ones.
Correct. The reciprocals are the early ones. Which one goes with which?
Cosecant is the reciprocal of sine.
Correct. Cosecant is the reciprocal of sine of theta. What does secant go with?
Cosine.
Yeah, the reciprocal of cosine. I'm going to abbreviate here. Of cosine, and there's only one left. The reciprocal of tangent is cotangent. So in other words, if I gave you, quick example, I'm going to give you an incomplete right triangle. You're going to have to test 3 different branches of math in this one. 7 centimeters, 25 centimeters, and let's call this theta. I would like you to give me sine of theta, cosine, tangent, cosecant, secant, cotangent of theta. Step me through these. How do you do it? So if you take this one, how do you get sine again? Right. Hop on to angle theta. What is the opposite? What's the hypotenuse? Yeah, so what's your final answer? Don't work too hard. 7 over 25. Leave it that way. I do not want a decimal. Unless I specifically ask for it, leave it as a fraction. How do you get cosine? Take another one. Yeah, what's the adjacent? Exactly. Please, for the love of all that's holy, I have seen this happen in many, many tests. Please do not do this. Please do not leave it like that. You can do better. That's true up to a point, but I want an actual answer. Can somebody find the missing sign? Show the C-shot. How would you do that? Pythagorean theorem. What is that again? Correct. And C is always which side? The hypotenuse, the longest side. So A and B you can plug in wherever, but C always has, the biggest side always has to go in the C slot. So go ahead and do this for me. It doesn't really matter if this is A or B. B squared, because I don't know what it is, equals 25 squared. What's 7 squared? 49. Plus B squared equals, I mean, 25 squared up there. That's 15 squared. Bigger.
Like 625.
625, nice. 625. Solve this, somebody. 2 steps to do it. Pete, help me out. I want B by itself.
You could subtract 49.
Yep. What do you get?
579.
570. 15 and 9.
576.
Yeah, 576. What's the square root of that? By the way, how many answers is the square root of? 2. What kind?
Positive.
Positive and negative. Do I want both of them?
No.
You can't have a negative for a length. You physically throw that away. Somebody know what the square root of 576 is? It's actually pretty nice.
24.
It's 24. Congratulations, you found the missing side. So what's the cosine? Anybody? 24 over 25.
Is that like one of those triangles, like the second, 24, 25?
It is what's called the Pythagorean triple. Right, it's a common. Sorry, I've got a cat here in my mask again. Welcome to my life. I swear the cat is on the other side of the building. He does not get into the kitchen ever. I leave this in the kitchen. What happens? Fur explosion everywhere. Anyways, moving on. This is called the Pythagorean triple. It's one of the. It's basically a cluster of three numbers, nice numbers, that makes a right triangle. Let me remember the most common and easiest one.
3, 4, 5.
3, 4, 5. There are many. There are an infinite number of them, actually. 3, 4, 5. Can we know other ones? One of them starts with a 5. Oh, geometry, remembering people. 5, 12, quite smaller. 13, 8, 15. Can we know?
17.
17, nice. 7, 24, 25. And there's 9, 40, 41. It keeps going. There are lots and lots of them. There are actually little techniques by which you can find those three numbers, whichever one you want. It's kind of clever. Well, Pythagoras actually came up with one of them. I'll tell you more later. For now, can somebody give me tangents? Michael, what is tangent of theta? How do you get tangent again? Sum over what? 24, correct. Opposite of adjacent. While you're at it, give me cosecant. How do you do that? You can actually do it very quickly. Exactly. Take sine and flip it upside down. Keep going. What's secant?
25
Yep. And cotangent?
24 over 7.
24 over 7. Done. Does that make sense? That's how you sine, cosine, and tangent. Oh, if you have the three sides that are known. Now, curious if you remember this from geometry and or snips and snaps of second year algebra. There are what we would call common trig shapes. And there are 4 of them. We're going to focus on 2 of them today, and then the other 2 tomorrow. The first 2, I'm almost positive you saw them. The first 2, I'm almost positive you saw them in geometry. Shape number 1, please write this down. The 30, 60, 90 degree triangle. The 30, 60, there's something that's just called a 30, 60, 90 triangle. I'm specifically going to say 30, 60, 90 degree triangle. Because what else can you measure angles in? Radians. I do not want a 30, 60, 90 radian triangle. It would be way too big, it'd explode. Can somebody refresh my memory? I mean, I can tell you one thing. One angle is 30, one angle is 60, one angle is 90. That's not the hard part. Can somebody remember the sides? These you need to memorize. It's a nice sounding pattern. Does anybody remember in the deep dark dredges of history? At least 2 years ago. Yeah.
Well, I know that some of them like square roots and all.
Correct.
And these one of those radical three.
The smallest side is 1, if that helps. And what was it?
Radical three.
The medium side is radical 3. The largest side is a whole number. 2. 1, 2, radical 3. 1, 2, radical 3. Not quite in that order. 1 is the smallest, radical 3 is medium. Radical 3, if you punch into a calculator, it's like 1.7 something, 1.732, blah, blah, blah. And then 2 is 2. So radical 3 is the medium side, 2 is the longest side. Memorize that. That will be on the test. You'll be using that continuously for the rest of the year. This and the next shape are going to be one of your best friends. Second shape, a 45, 45, 90 degree triangle. Now, geometry people. If this is 45 degrees and this is 45 degrees, I'm curious if anybody else can tell me something that must be true about that triangle.
Well, the two not hypotenuses, I don't know what their names are.
Okay, they're called legs.
But, well, they have to be equal,
Yes, why?
because, both the angles are 45, which means their sides are equal to.
Correct. If two angles of a triangle are the same, then the cross sides, the opposite sides, also have to be equal. That's true. What kind of a triangle is this, by the way? I know it's a right triangle, yeah, but it's isosceles. Any triangle where two sides are congruent, same shape, same size, is called isosceles. This is an isosceles right triangle, also known as a 45, 45, 90 degree triangle. Does anyone remember the sides for this? I'll tell you right now, this is one. One of the other ones should be really super duper easy. So, what's this one? It better be one. Does anybody happen to know what this one is? You can use the Pythagorean theorem if you need to. What?
Radical 2.
It's radical 2. 1 squared plus 1 squared is 2. Square root of 2. Memorize that. 1, 2 radical 3. 1, 1 radical 2. Memorize those. The reason is because out of the blue, I'm going to say, does everybody have a calculator? If you don't have a calculator, grab one off the table over there. I have several laid out for you. Or grab it from your bag, that would be good. Can somebody give me approximately the cosine of 12 degrees? And whenever you have a wavy equal sign, that's an approximate symbol. That means you're going to have to round off. It's going to be some sort of weird decimal.
0.9, 7, something.
Yes. Tell me what it is. Give me 4 decimal places.
I accidentally just clicked out of the X.
Oh, okay. 0.9781. Correct. The next digit is a 4, so it rounds down. So cosine of 12 degrees is roughly 0.9781. Just out of curiosity, you should have typed in cosine and then 12. Did anybody happen to get 0.8439? Okay. We need to switch your calculator from radian mode to degree mode. So in the upper row, not the upper row, but the first one where there's seconds and then mode and delete, hit mode. Third row down. There's one choice for radians, one choice for degrees. If you have a graphing calculator. Select degrees. Okay, if you haven't, please do that now. Okay? Did everybody get cosine is roughly 0.9781? If you did not give me that, tell me now. Otherwise, I'll assume your calculator's fine. If you have a smaller calculator, there might be a key that says DRG. That switches from degrees to radians to this third category that nobody ever uses anymore called gradients. So DRG. In other words, if you didn't get that decimal, let me know and we can fix your calculator. Is this an exact answer to this issue? No, it is not. What if I did this? I want an exact answer for the cosine of 30 degrees. Type in cosine of 30 degrees on your calculator. What do you get? 0.8660, blah, blah, blah. Yeah, that's what I got too. If you put that on a calculator, on the test, 0.866, even if you got everything, 0.2, I get a lot of decimals. I say, well, that must be safe. I would take off 7 out of 10. Maybe why?
Do you know what the cosine of 30 is?
That's not exact. Can you tell me what the cosine of 30 actually is? An exact fraction. I'll give you a hint. Did you what? How do you get radical 3 over 2? Look over here. Cosine is adjacent over hypotenuse. Boom. Just write the fraction, you're done. Radical 3 is exact. Point blah 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 is not. Clear? Any questions? Hold tight, let me get your assignment off the printer. This is not due tomorrow. This is due Wednesday. Because I'm going to have a few more notes involved in this, but I want to show you at least a few of these that we will be able to do. They're few and far between. Some of these angles might look kind of big. No problem. Now, how are you supposed to do angles that are really huge? Right now, on page 1, there is one problem out of the 10 that you should be able to do given the notes that I've given you today. Does anybody see which one? Number 5, cosine of 60. Can you get it for me? What is the cosine of 60? What is cosine again? SOHCAHTOA. Adjacent over hypotenuse. Hop onto the 60-degree angle. Give me the adjacent, give me the hypotenuse. And you make a fraction. It's actually kind of nice. Other way around.
Oh,
1/2. On your calculator, by the way, type in cosine of 60. What do you get?
What's that?
0.5. That's called lucky. That's one of the few angles where the calculator will give you an exact answer. Usually it will not. You have the power to get exact answers where the calculator cannot. Unless you have one of those fancy schmancy cooked breakfast for you calculators that turn things into radians. I have seen, I will not mention any names, but one of my calculus students happens to have one of those. And I wish those would burn in one of the pits of donkeys and
Like, can you say who it is so we can ask them?
I shan't, no.
Is it Caleb?
I'm not even gonna say.
Caleb's not a calculus.
Not saying. So, moving on. The, again, this is not gonna be due tomorrow, it's gonna be due Wednesday. Please write the following down. The third shape is called the unit circle. Remember this? We touched on this last year. I'm gonna refresh your memory on it. The unit circle is arguably the easiest circle to graph. If you had to graph an easy circle, where would you put the center? Like what, comma what? Like to make it boneheadedly easy. Go. 0, 0. That's exactly what I would do. And that's what they're doing. The center is at 0, 0. If you had to choose a radius, other than 0 of course, because that would kill your circle, what radius would you use to make your circle absolutely fall off the log easy? Exactly. I'm going to make it a radius of 1. And by the way, if your circle doesn't look like a work of art, don't worry about it. Mine doesn't either. It looks like somebody stepped on it. It has a radius of 1. By the way, that's where unit circle comes from. Uni means what number? 1. Uni means 1, so it's a radius of 1. Draw a radius up and to the right. Please put theta underneath it. So there's three things we know about the unit circle. The center is at 0, 0, because it's easy. The radius is 1, again, because it's easy. The angle is theta. I think we were talking about this the other day. Do you remember, was I telling you about why the quadrants are graphed, quadrant 1, quadrant 2, quadrant 3, quadrant 4, the other week? Okay, didn't remember why? Where's angle 0? Remember? Where on the circle? Yeah, Pete.
Isn't it like, well, in the first part, you're talking about like the measures zero?
Yeah, the 0 degree angle, where would I put it? Like what part of the circle?
Oh, so it's, well, the top
Is-
half and that's on the very right, right?
Yeah, it's right over here. This is the 0 degree mark. And then what would this be? 90, correct. If you go backwards, this would be negative 90. Or if you went forward, it'd be 270. Does that make sense? Those two angles would work for the same spot, depending on which way you go. Going this way is positive. Going up is positive. Going down is negative. Make sense of that? There was one last thing. The location of this mystery point. Where is it? Somebody happen to remember from last year? Otherwise, we'll find it in about 3 minutes. Stay with me. We're close to the end of the hour, but not quite. Do me a favor. If you have not drawn this circle in your notes, please do so now, because we're going to dissect it. You're going to have to draw some diagram stuff on top of it. So 3 things to note. Center is 0, 0. The radius is 1. Theta is below the radius, because it's from 0 to this. So this might be 40 degrees, it might be 35, who knows. So if you open it up, it might be like 50 degrees, 40 degrees, etc. I want to know where this point is, what comma what. I have no idea, other than the fact that I'm going to drop a little dotted line here. Guess what shape I just made? That we've been playing with a lot. What is that? Yeah. It might be 45, 45, 90, depending on how big this is. But it's at very least a what triangle? A right triangle. I don't know how long this is. I'm just going to call it X, because I have no idea. Over here, look up here. I'm going to call this Y, because I don't know what that is either. Does that make sense? I have absolutely no clue. But does everybody see that this point would be X comma Y? X is how far over it is, and Y is how far up it is. I still don't know what the numbers are. Question. That right triangle that we drew, can somebody tell, this is theta. I just surgically removed this right triangle. How long is this side? This issue. It's 1. How long is this? I mean, I don't have a number, but I have something. What was I calling it? Y. And what was I calling this? Exactly. That's all I know. That's all they knew about 450 years ago. They were playing with this stuff. They had just discovered sine, cosine, tangent. Just for giggles. Can somebody do SOHCAHTOA for me? Sine of theta. Just nothing but this. There's a trick to it, of course, but not trick question. Pete. What's sine, whatever what? Opposite of hypotenuse. What would you get? Y over 1. What is y over 1? It's y. We just found out that y is equal to what? You have just found part of your point. The height of that mystery point is the sine of theta, which will be some weird decimal usually. We found this by accident, just by playing with trig. Can somebody just play with trig and get cosine? Jack Cloud.
So you've got,
Just use this thing.
adjacent over hypotenuse, so x over one.
X over 1, better known as
X.
x. We now know that x is equal to cosine of theta. The mystery point has been discovered. It's cosine of theta comma sine of theta. Depending on how big your angle is, these two decimal numbers will change. You tell me, if I give you an angle, here's a unit circle. Wow, this is a horrible circle. That's just great. That's better. I'm going to make this 10 degrees. Unit circle where the center of 0, 0, radius of 1, and the angle is 10 degrees. Can somebody give me an approximate location of that point? Use your calculator. Give me 4 decimal places. What comma what? Raise your hand when you think you have one. Does anybody have the first coordinate? Because does it make sense that it's going to be something less than 1? Because all the way over to the end is 1. So it's a little bit to the left of that. So it's like 0.9 something, 0.8 something, something like that. Yeah.
Isn't that like negative cosine?
That's coming up later.
Oh.
For this one, it does see it's somewhere between 0 and 1, and it's probably closer to 1. What do you get?
0.9848.
I got that too. 0.9848. How'd you get that?
You type in cosine of 10, negative 10, because, x.
Yeah. How do you get x? It's cosine of the angle you're using. That's all you do. Calculator is going to be a good assist on these. Not always, but sometimes. Can somebody give me the height of that point? It's going to be pretty small. It's going to be something like, this is the height of 1, and it's a lot lower than that. I bet you probably less than 0.5. Can we get it? Yeah.
0.1736.
0.1736. How do you get that?
Sine of theta.
It's sine of the 10 degrees. That's how you find mystery points on the unit circle. Its cosine is how far over it is. Sine is how far up it is. Yeah, it's not good.
Where did you get the 10 degrees?
I just picked that up as an example. So I could pick any angle I wanted. I could do 120 degrees. I could do 299 degrees. And the calculator will give you the coordinates, roughly. So here's my question for you. What did you say? I'm going to draw one more unit circle. I think. What time is it? Yeah, one more, definitely. I want to make this 30 degrees. And if this is a unit circle, center 0, 0, radius 1, can somebody give me the exact coordinates? Not decimal coordinates. Exact. Who thinks they can do it? How far over is it? Tell me how you get it. Like, what would you punch into a calculator if you wanted, if you had a calculator and you wanted to? Good.
Like cosine of 30.
It'd be cosine of 30.
Equals 1, x over 1.
It's x over 1. Now, do you remember 30 degrees showing up somewhere before? Use it. What's the cosine of 30? Michael. Use that 30, 60, 90 triangle and get your answer. What's the cosine of 30? Guess what you just found? That's the exact far overness. It's like approximately 0.866. Blah, 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 blah. I looked at this earlier. Don't be too impressed. Can anybody give me the height? Do this, Sean. How do you get the height? The far overness is cosine of 30. Sine of 30. What is that? Can you give me the exact answer? 1/2. Congratulations, you just found the exact answer. Tomorrow, I'm going to give you a little bit more of how to get angles that are much bigger than 90. Like if I give you 120 or 150, you should be able to give me the exact coordinates. I'll show you how to do that tomorrow. For now,
Really have to do
for tonight, no. This whole thing is due Wednesday. If you want to try and work ahead and try and muscle it out, feel free. Otherwise, don't worry about it. Get some sleep. Including you people at home. God bless you all. And we'll see you all later. We're going to pray. We'll keep you in prayer. See ya.